Significant figure. Before studying significant figure, we should know how to write the observations or the readings. The most scientific way of writing a reading is to put the decimal after one digit, and remaining we shall express in powers of 10. Now, what are the significant digits? When we measure, the last digit of any measurement is always subject to uncertainties because that has to deal with the least count. Least count means the smallest possible division. So in any reading, there are many certain digits and one uncertain digits. These together shall be known as significant figure. In short, we can say greater the number of significant figure, greater becomes the accuracy of some measurement. There are certain methods to follow the counting of significant figures. Here you can have a look at. First thing is that all non-zero digits are 9 in number, starting from 1 to 9, and 0 is only 0, that's one digit. So all non-zero digits are significant, like here. You see, these are all non-zero digits. Here you'll say 3 significant, here you'll say 4 significant figure. And zeros would be counted as significant only when they lie between two non-zero digits. For example, if you write this way, then here 0 is also significant. So if the 0 is lying between two non-zero digits, that would be counted as SF. Now, what is leading zeros? What about leading zeros? They would be counted as SF or not? No, not at all. All the leading zeros means lying before first non-zero digit. For example, 0.04030. This is leading zero. Leading zeros will never be counted as SF. So here it's not counted as SF. 1, 2, 3, 4, 5. 5 SF are here. Then we have to see what about the trailing zeros. Trailing means in the last trail, the last coach of a train, trailer you say. So trailing zeros means lying in the last, say 0.4700. These would be known as trailing zeros. Trailing zeros will be counted as SF if there is decimal in the reading. If decimal is not there, like it was 47, then these will not be counted as SF. So one thing to remember is specifically, if there is decimal in the reading, trailing zeros will be counted as SF. If there is no decimal in the reading, trailing zeros will not be counted as SF. You see, in the base number, I told you for writing a number scientifically, one has to put decimal after one digit. Suppose this is 3.457 into 10 to the power 3. These powers, these exponents, will never be considered as SF. While counting SF, you need not bother about this. The only thing is base number. In base number, the digits would be counted as SF. So how many SF are there in this reading? There are 4 SF. Now on changing the meter, obviously the powers will change. But by changing the power, base number is not going to change. Decimal might place from here to there, but base number SF will remain unchanged. For example, I have shown one reading here. You see this thing 4.700 In meter, if you convert into centimeter, powers will go on changing, millimeter and like other systems also might be chosen, but each time this will remain unchanged, 4.700. So SF will remain unchanged.